So the final rule is Hunds Rule, which says for electrons with degenerate orbitals, the lowest energy is obtained when the number of electrons having the same spin is maximized. Okay, that sounds really complicated, but in all honesty, it's very, very simple. Okay, so when they say degenerate orbitals, what they mean by that is that they're orbitals with the same energy. Okay, so let me go back to my electron configuration for just a second. I want to point out something. You see these 2p orbitals? Each one of these boxes represents a 2p orbital, right? Notice they're all at the same energy. Okay, so this is what it's referring to. If you have multiple orbitals with the same energy, then you want to, the lowest energy is obtained when the number of electrons having the same spin is maximized. Okay, so what that means is that basically you want to fill all of the electrons in these p and d orbital or subshells. You want to fill all of those electrons first, all of them with all the arrows pointing the same way, and then start filling in later. Okay, so if I'm going to show, I'm going to show two examples of this. I've got carbon and nitrogen. That carbon's got 6 electrons, nitrogen's got 7. Well, if I start filling in electrons, I put 1 electron here, second electron there, right? Because this is the lowest energy. This is the next lowest energy, 1, 2. So that's 4 electrons I have accounted for. I need to put in 2 more. So my options are I could put 1 here and 1 here, or let me pause it for a second. Or I can, whoops, still got the eraser up. Or I can put 1 here and 1 here. So I'm putting them with the spin the same way. So this is, imagine this as being representing plus 1/2 and plus 1/2 for the m sub s quantum number. This has a lower energy. And so if we go use the same rule down here for nitrogen, we put in the first 4 electrons just like for carbon at the lowest energy possible, and then the lowest energy for the next set is with the 3 electrons remaining all having or pointing in the same direction. Instead of putting an electron here and an electron here, we're putting 3 electrons in the orbitals all facing the same way. And that attains the lowest possible energy for nitrogen.